Hi everyone, welcome to today's video. Hope all of you are doing great. All are going good, right? So today I'm gonna discuss in this video about one of the BGP attribute, that is the local preference, right? And this video gonna one of the BGP series tutorial video, right? So I'm gonna explain the BGP local preference, one of the important attributes, and how to use that. As I said, I'm going to explain the BGP local preferences attribute, right? And this is one of the important attribute. Why? Because it comes in number two. What is the number two and how the BGP based path selection that I have explained in separate video that you can check out from the I button or from the playlist anyway. So let's get started. Well-known attribute, we know it's a well-known definitely, and why well-known I have explained earlier. And though it's a discretionary, but thing is that it's local to AS, right? It's travel within the AS that I will also show you. Now another part is that used to manipulate to outbound traffic, right? From in to out in terms of or in respect of data plane or forwarding, right? Now we have also explained, and we all know that higher is preferable, right? By default the local preference comes with this value 100, that is the default. Now if you increase that value, that would be the preferable. All right, so I hope you understand this basic thing, but let me take you to the lab wherein I will explain with a real requirement or a real scenario, so that you can understand or apply each and every part and understand easier way, better way, right? So let's go to the lab. Yeah, here we go. So let me introduce to this lab first to you. Let's have a basic understanding of this lab, right? So this is IBGP full mesh topology, right? And there is a router. In that router, one server is connected, right? And this is the router 6, which is the EBGP neighbor of the IBGP mesh, and that router 6 connected with the another server. There is two important or major server that gonna use by these two hosts, or rather this two network, right? So who is source? Source is this. Now our requirement over here is that this host, if wants to reach this server, in that case the path should be this router, then it should take to the router 3, right? Then from here it can choose any router, right? Because it's a IBGP neighbor. But thing is that over here we want to choose this router 1 because it's closer, right? I would say it's a closer and it's take the right, and in our requirement this router is the high available router. That's what we are choosing, right? Anyway, so anyway, this is the best path. That's what we have selected. This is how the traffic should be go, right? Anyway, so this is how the host C can reach to the server 10 network host A, right? This is also one server, right? And that packet should travel this path. Another thing is that if this host C wants to reach the 10 or 20 network, in that case it should take this path, right? Very simple, transparent and crystal clear demand and requirement we received from the management team, right? Or network team, anyway. So let's do that first. Let's log in and let's see which path it's take, right? All right, so let me take you to the configuration part. Let me log into the router 7 over here. This is the router 7, right? For your understanding, I'm gonna run again the same command to check which path it is taking by default, right? So how do I check that? So IP BGP, right? So here it's clearly says that to reach this network, this router 7 having two path, 11.2 and 11.2 and the 10.2. Now who is 11.2? Let me so who is 11.2? He is 11.2, right? This path. And who is 10.2? This path. To reach this 10 network, this router 7 having two paths, this path and this path. Now thing is that which path he has selected by default, by following the tiebaker mechanism, right, tiebaker methodology, he has selected the best one, right? This is how we understand the best one, and this is the path. So this router will take this path to reach this destination. That is fine, as we expected. This is how it should, right? It's not this is how, but by default it's selected, right, this path. Anyway, so let's log in to the router 3 so that we can check whether it's take the router 1 or router 2, right? All right, here also what will run the same command, so IP BGP, right? Over here what we'll check, we'll check to check the 10 network, how many paths we have. Having two path, 3.2 and 6.2 definitely, right? So again this router having two path, 6.2, another one is the 3.2, right? And which one is the best? By this we can understand this is the best one. Who is the best one? 6.2. So again by default it's take, that is the expected, right? Now from there who gonna choose the start network? Let me show you. Okay, this is the BGP configuration. I will also show you. Yeah, so again the best path selected the 15.2, right? So as we plan, it is selecting this path. Now another plan we have that this path should take to reach this server, right? So let me log into the router 7, right? Here is the router 7. Yeah, but to reach this 20 network, it's mean this network, it take the 11 to 10.2 is the best path, right? Which we don't want. We want this path should take via this, and this, right? Now this is the thing we have to manipulate. We by force using local preference, we force the traffic from this path to this path, right? All right. So first our requirement is to reach this network, we will take this path, whereas it's by default take this path, right? It's take this path, but our objective is to send the traffic with this path. So for that what we'll do, we'll configure the local preference. Now let me take you to the basic configuration, because I will explain the configuration to you because 2 to 3 way I will show you how to configure this thing. So this is the configuration. Basically I already prepared to save the time, right? Because for the explanation it takes time. Anyway, so to apply the local preference, we need to do 3 things, right? First we have to create one prefix list, then route map, then we have to apply. The same thing I have configured, make ready, and already configured, though still I will show you, right? So here you can see first we will create prefix list, but here I have configured for the 10 network also, right? Because but the thing is the 10 network already taking the right path, that we are not gonna change, right? If it is not, then you can use these configurations. Anyway, so we will apply for this network, right? So first we have configured one prefix list. Prefix list is nothing but so that we can call this network as a name. This is the name in future, right, for this network. This is the prefix list meaning. There is no other meaning over here, the simplest way, right? Now another thing is that we will then create a route map. Now what route map will create? Route map, now this is the name, right? I put the name local preference, and the route map name is local preference, but thing is that I have to allow permit the sequence number. Any sequence number you can put, 1 2 3 11, anything, right? All right, so what this route map will do, match IP prefix list, right? And this is the 10 network, right? So to who is 10 network? He is 10 network, and against this who is 10 network, he will call this body, right? But thing is that we are not going to implement this because it's taking the right path. We are gonna implement the second path one, right? So what we will do by here, we will create again another route map. The route map name will be local preference and hyphen 300 or dash 300 and permit with the sequence number because we are permitting, right? So the route map name is the local preference 300. Now what will match on that route map? Match IP address prefix list 20 network. Who is this 20 network? Right? Let me take you to that 20 network. Right? So once you call, he will call my name is this. See, he belongs to over here. Now you putting one name over here, and now you are going to call on this route map, right? All right, then we'll call definitely, but thing is that we are gonna set the local preference over here. This is the point we are gonna, this is our subject, right? This is our objective. We're gonna manipulate, we're gonna put the highest local preference for this network, right? For this 20 network. So 300 is more than 100, right? So that is the fine to prefer the route. Now what we do, we create a prefix list and that we map to the route map, right? And now we gonna apply. We create prefix list, we create route map over here, right? And then that we gonna apply in this neighbor. Hope you understand. Now another part, keep in mind in your any deployment that please put this command because you have to allow, right, route map local preference permit 13 sequence number, right? Why I am permitting last? Because it's the first route map will comes with the implicit deny, right? If you allow this and you are not putting this command, it will implicitly deny other network. What will happen in that case if you don't put that? Let me show you here. You are getting for this network right, two path, right? But thing is that if you don't put this permit explicit allow, right, to avoid the implicit deny, right, in that case this two path gonna show you, otherwise it will not show you, right? It's gonna deny. Anyway, so let's get started. So that's what I'm gonna show you. The configuration already I did over here. Sorry, I just wanted to close it a bit faster. Yeah, so here I configure, but thing is that we gonna implement for this network only because it's as expected, it is by default work. That's what we're not going to implement, though you can implement, right? You can implement in future. So anyway, so our objective is that, our motto is that this is the prefix list, right? And this is the name as I explained, and that we're gonna call for this route map where we are selecting or setting the preference 300 and we are calling 220 network, that is the prefix list, and the prefix list name local preference 300. Now this route map we gonna apply, where we gonna apply, let me show you. Yeah, so where we gonna apply this neighbor, right, for the 11.2, so that the traffic should goes through this. Okay, alright. Now there is no route map is enabled, right? I'm gonna enable, or rather apply. It's called basically apply, right? Which one? Now I'm gonna apply this one, right? So this line states that this neighbor use the route map local preference this name, right? And this name will prefer the highest local. Let me explain to you again. I'm gonna apply for this neighbor, this route map, right? Now this route map, what says over here, this is the route map, it is setting local preference, right? Local preference 300 for which network? That is the network 20 that I have already explained to you, right? Which one is the 20 network? All right, so let me apply this thing to here. Where is the route 7? But before that, so IP BGP, let me show you. Do show IP BGP, right? So for to reach this network, which one is the best? 10.2. Our objective is to make that 11.2, right? So we're gonna apply this. Sorry man, this one. This is the router 7, right? Now I'm gonna apply. Now how it looks like, I'm not enabling debug to explain, it will take more time. Yeah, so I have applied the route map for this neighbor, right? Now what I'll do, for time being I will clear IP BGP stop. Let me take it soft, otherwise it will take more time. All right, so we know, right? Now the path earlier it takes the base one 10.2, now it should take 11.2. all right, so IP BGP, where is that? Yeah, here it is. So IP BGP. Now hope you understand, right? This is the best path as we want, right? Earlier which one was the best path? 10.2, right? Oh sorry, for 20 network 10.2 was the primary, right? Through this is the best path. Now which one is the best path? 11, right? Through this you can understand the best path, right? And why it's become the best path? I put the local preference 300. That is why it is taking the highest preference. So as we want to reach, it is by default took the best path. Now we manipulate this network for this path by using local preference 300. This is the one way I show you to apply the local preference. Another way, let me take you to the diagram again. Yeah, so here it is as we expected, it is taking this path to reach this destination, right? All right, now thing is that we have to check from here also, right? After reaching over here, which path it is taking, right? Is the path. So IP BGP for the 20 network, it is taking 4.2 is the best path. Which one is the 4.2? Oh sorry, just a minute. Yeah, so router 3 and 4, for the router 4 you can see the best path to reach the 4.2 is this. So again it is taking a different path, it's not expected, it's going to there, then again it goes to here only, right? It should not be. Now we have to manipulate this network, right? Now here our objective is to show IP BGP to reach 10 network, it should be take 6.2. that is perfectly working as we expected. This path to reach this distance should take this path, and for the 20 network it is taking 66, right? Again it's not expected, right? So both the path to reach this destination as well as this destination, it is taking a single path, that is the there, right? But though it should take for this network this, and for this network this, right? So we have to play around with these two router 1 and 2. that let me show you how do I do that. I have to apply on router 1 to make this 10 network, this is the best path. How do I do that? Let me show you. It's very important and interesting, don't miss out. It's not the basic local preference, bit more clarity, bit 3 different way I'm gonna explain you. Yeah, so router way, you can see that the way I'm putting, I'm not creating any local preferences over here, right? Hope you understand, because see this is another way, that is previous one, the one way, this is the another way I'm gonna show you. Now in this path what is showing that I'm gonna use local preference 200, right? To for which network? For any network, whatever I'm learning from here, right? any network, right? So whatever network learned by router 1, in that case router 1 gonna the higher preferable. Now how do I do that? Let me show you. So run section, right? Nothing is applied. Now I'm gonna show you the attribute or the local preference route map is already configured over here. You can see nothing I did, right? Here I said local preference name, I put the one local preference name, and that local preference I'm going to set the 200, and that I'm going to apply for over here, right? So let me apply. This is the another way. Now how do I apply? All right. Oh, bit. Yeah. Now here I am apply. Now meaning of the apply, here I am putting in. Keep in mind, always in means inbound traffic. In means it's we are going to manipulate the outbound traffic, though we are putting the in, because whenever we put in the route map, it will apply in terms of control plane, not data plane, right? To manipulate the outbound traffic, we'll apply the local preference inbound control plane, right? Then only it will work, right? So what we did, we prefer the 200 for any network, that gonna learn by this router 1, right? So let me now, so IP BGP in router 3. Let's see, this is the magic, right? So here you can see the 10 network gonna a single path 6.2, and why? Because local preference is 200, right? Hope you understand. Now again, this is not changed yet. This network is not changed yet. Again, it's take the 6.2 path. We have to manipulate this path, right? Because both the local preferences are 100, right? So to some extent we make one expectation demand that is fulfilled. Now we'll manipulate this network so that by force it goes to this network, right? Now that local preference I'm going to show you in different another way. Now this is the local preference, right? There is no difference from others. Difference is that we gonna apply in out, right? You might rarely seen out, but as it's possible, that's what I'm gonna show you in with the out also, right? But it's not recommended though. Why recommend? Not recommended. You have to study your network flow, route policies, all these things, then only use the out, right? Even in also, after properly study your network. Otherwise it is gonna fully mess, right? By default not IBGP mess anyway. So yeah, so this is the local preference I'm gonna apply, where that is router 2, right? I have not logged in yet. Router 2, let me here you can see the route map I have configured, right? How I configured, as I saw earlier, the same way the prefix list, the 20 network, and this 20 network is this, and that is being called over here as a prefix list name, but we are preferring with the 101 value. But thing is that over here we are going to apply in the outbound. All right, so run section BGP, right? So how we gonna apply? This is how we gonna apply. right? Now let me explain you why I put out. This is very important. Now here we manipulating the local preference with the outbound. Now what I said, for this network, right, whatever I learn the path, right, I'm gonna 101 value, and this I'm going to apply for you, right, out for you, for you, right, that I am gonna declare I am the highest local preference, that is the 101 for this network, and it is out. So now once this router 3, router 1, router 4 gonna receive this network, it will receive that local preference for this network is 101, then that is the router 2, right? Now every network should reach router 10.20 with this router only, right? So let me show you that also. It is bit important, right? Local preference. Now here you can see, as we manipulate for 10 network, I'm checking from the router 3. Please keep in mind that is the 6.2 as expected. Now for the 20 it is 3.2. Why 3.2? Because I manipulate with the 100.1. And why 200 is for this network, right? And why now here is the one catch you have to understand. Let me show you. Where is the router 7? Here is the router 7. Yeah, so here you can understand one thing, that from router 7 it is 300 local preference swing, that is the local to the router. But thing is that we apply local preference in router 1 as well as router 2, but we can see that local preferences in over here, right, in 200 101, right? Why I am saying it's visible to me? Because it is populating from here, because it's a IBGP neighbor, right? So local preference, as I said, local to the AS, right? So whatever I am configuring local preference over here, that gonna learn by other all IBGP neighbor. But if I configure over here, no one gonna learn, or this local preference not gonna travel over the eBGP, right? So now as expected, the traffic should travel over here, right, and this way, right? All right, now let me show you how the traffic is traveling. Okay, it's already a login, that's what it is showing, like this way. Just a minute, host C. Yeah, so let me show you. I can reach this body earlier also, I can reach, but just a minute, 20.10. Yeah, I can reach both the network, but thing is that I have to check, am I able to reach as we manipulate? Right, now let me explain over here how it is reaching, right, for this network. So this C network wants to reach this server. How he is reaching? First hop he take 172.16.1.1, that is fine. Then second is the 10.2, this is the 10.2, right, reach over here. Then second one is take 6.2, right. Then second, the fourth one rather, that is take 15.1, right. From there it's reached the destination. Earlier it's nothing we manipulate, but though we have manipulate over here for this network. So as we plan, it is reaching like this way. Now we will check another thing. Let me show you. Let me trace this. Oh sorry. Yeah, now how it is reaching, it should reach as expected. It goes to over here, then it's take this path 11.2, you can see, right, and then it's take 5.2, right, then it's take 12.1, right? Then it's take landed the traffic to over here, right, as expected. Now hope you understand and it makes sense. I know it takes time, though you understand. Hope it is right. We can apply in three different way local preference. There is other way out also, but I can show you three way. One is the for any network I'm gonna learn that gonna be highest local preference. That is the one way. Another one sorry, another one way is the I can manipulate exactly the network, and that I'm gonna apply in previous one. Also I'm gonna apply in directions. The second one also gonna apply in direction, but we are filtering the network, specific network, right, by making the local preference. The third one, the same way, we are filtering the network, preferring with the local prefix list. But thing is that I'm gonna apply out segment. Now what happen in out segment? Whatever route, let me show you, whatever route, right, it's not whatever, whenever this route gonna learn by this router, that gonna highest preferable with the value, right? And the value is local preference is how much? 101. That is what it is showing right over here. It is very transparent and crystal clear, right? One is for 10, I manipulate in the router one, that is 200 local preferences, and for 10 or 20 network I manipulate 101 network, right? Even that is what this network going through over here. Earlier it is going through over here, right? All right, hope it is making sense, right? Yeah, thank you.